Same thing, we want to make the left-hand side look like the right-hand side. Does anybody see the pattern on the left? This is the factoring of a difference of squares, right? If I had a squared minus b squared, that's a plus b times a minus b, right? So that is secant squared theta minus tan squared theta. If you're not sure about that, you could FOIL them, right? FOIL them, make all four terms. The first term would have been secant times secant, secant squared. The next term would have been secant times negative tangent. The next term would have been secant times positive tangent. Those two are opposite, so they cancel. And the last term would be tangent times tangent, tan squared. So you could FOIL them, or you can recognize this is the difference of squares factored. So this is the difference of squares. And we still don't have the left looking like the right. What substitution? Which one of our identities that we've seen relates secants and tangents in the same identity? In fact, it relates secant squared and tan squared. One of the Pythagorean identities, this one right here, right there. We have an identity, something we know is always true, that will let us substitute for secant squared 1 plus tan squared. Right? Let's see. Add, what you're saying, add tan squared to both sides? Okay. Again, I would consider that a little non-conventional, but that's okay. Secant squared theta minus tan squared theta plus tan squared theta. So you're saying let's add tan squared to the left, and we'll add tan squared, that's a wrong squiggle, tan squared to the right. Okay, on the left, you can simplify the negative tan squared plus tan squared. They cancel each other out, and all you're left with is secant squared. On the right, we've got the 1 plus tan squared. And then we can use the identity directly. 1 plus tan squared is secant squared. So check. So, you know, what he did is fine. You might have at this step just substituted 1 plus tan squared, and then the tans would have canceled, and you would have had 1 equals 1. So there's more than one way to do these things, and they're all fine as long as you've done everything correctly and you've gotten to a place where the left side equals the right side. It's good.